In this tutorial, we saw how to build deep neural networks by stacking layers like inside a sequential model. By adding an activation function after the hidden layers, we gave the network the ability to learn more complex, non-linear relationships in the data. In these exercises, you'll build a neural network with hidden layers and then explore some activation functions beyond rectifier linear unit, ReLU. Can I say that? ReLU. Run this next cell to set everything up. Okay, I'm going to run it. I can see it's importing, setting some kind of style for the plot. It's going to plot something, I think. Just making sure the plot is initialized. So set up feedback system from learntools.core import binder. Binder.bind globals. From learntools.deeplearning_intro.ex2 import star. Okay, sorry, I'm not. Did I just start reading code? Right, I've already run this. In the concrete dataset, your task is to predict compressive strength of concrete manufactured according to the various recipes. All right, so we're going to be doing building today. Concrete. Run the next code cell without changes to load the dataset. Pandas. This is a panda data frame that we're going to be using to read the... Oh, what happened there? Always the second time. Okay, so we can see the table, cement, some kind of quantity here, blast furnace slag, I have no idea what that means, fly ash, water, super plasticizer, coarse aggregate, fine aggregate, age, compressive strength. These are just numbers at the end. Let's see what they ask us to do. Right, so the target for this task is the column compressive strength. The remaining columns are the features we'll use as inputs. What would be the input shape for this data set? Okay, let's do some counting. So the target is compressive strength. So we're going to exclude this. This is our output, right? This is what we're trying to predict. So 1, 2, 3, 4, 5, 6, 7, 8. So input shape equal to 8. I'm sorry, I'm sure I got something wrong here, but okay, it's correct. So 8. So easy. Number 2, define a model with hidden layers. Now create a model with 3 hidden layers, each having 512 units and the ReLU activation. Be sure to include an output layer of 1 unit and no activation, and also input shape as an argument for to the first layer. Oh my goodness. I'm going to have to copy code, sorry. Okay, I'll just create 512, no big deal. So let's just go to the previous code where thankfully they have this code already ready for us. So, but this is, of course, I need to change it, right? Because you can't just copy code and hope this works. First of all, they said 512 units, and the ReLU, I can keep it the same. The input shape, they said it has to be like 8, right? Like the one we had. So I guess I could just put it here as an argument, so I don't have to repeat it. Notice it should be okay, even though it's the same name. Right. So how many layers? We need 3 hidden layers. So this is the first layer. Hang on. How can it be the... Yeah, okay, these are hidden. All right, that's what it means. Okay. So 3 hidden layers, so I need 3. So 1 more. Okay. So 3 hidden layers, each having 512 units and the ReLU activation. And be sure to include an output layer of 1 unit and no activation, and also input shape as an argument to the first layer. So in fact it's the same as this one, right? So I've done what they asked. Let's try it. Feeling confident today. I was wondering, that's an extra comma, right? It's not that. I wonder why it's keeping... It seems to always fail the first time. It happened also in module, in the first module. I always have to run the cell twice, but it works. So I got it right. It's not too difficult, it seems. Okay. Okay, next, number 3. And number 3 is about activation layers. Let's explore activation functions some. I don't know what that means, but kind of makes up a sentence. The usual way of attaching an activation function to a dense layer is to include it as part of the definition with the activation argument. Sometimes, though, you want to put some other layer between the dense layer and its activation function. We'll see an example of this in lesson 5. Okay, I'll get that soon. With batch normalization. In this case, we can define the activation in its own activation layer, like so. Layers.dense units equal to 8 and layers.activation ReLU. I'm a bit confused because I thought, so these layers already have, okay, so I'm going back to where I was. These layers already have an activation function, right? So are we saying that we are going to add an activation function at the very last layer? Is that what this is about? So let me just kind of read to myself again, just to see if I understood what I was reading. Okay, what it's saying here, right? It's basically that although you can actually have an activation function as part of the layer itself, like we've been doing, right? This is the activation. It's already included in the layer. But you can actually create a layer on its own with activation function. So this is equivalent to that. But in general, you would only do this if you had something between these two, right? Just a thought. Okay, so I'm back. I think I can continue. So the exercise is basically to convert the previous model here into, so to have a separate activation layer for each. Okay? So I'm going to copy and paste this guy, right? And then put it here, and I'm going to do that the same here as well. So I'll take the activation away, leave the input shape. Okay, and that's it. Okay, it's correct. So to be honest, this is not too difficult, but the optional exercise is coming. So what do we have in store for us? Alternatives to ReLU. Okay, so we've seen the rectifier linear unit, which is the function we've used so far, and now we have more, of course. There's a whole family of variants of ReLU activation. ELU, CELU, and Swish, among others, all of which I've never heard, by the way, all of which you can use in Keras. Sometimes, one activation will perform better than another on a given task, so you could consider experimenting with activations as you develop the model. The ReLU activation tends to do well on most problems, so it is a good one to start with. Let's look at the graphs of some of these. Change the activation from ReLU to one of the others named above, then run the cell to see the graph. Okay, let's try ELU first. ELU is like the ReLU without the R, right? So I'm just guessing, maybe it's not a rectifier, but who knows? Let's see. Okay, so it's like a curve. Let's just see what ReLU looks like. We know it's like a rectifier, like a flat line, and then it goes up, right? Right, so the graph for the ReLU, right? That's easy enough to understand. And then we have ELU. So this is ELU going up. Then we have CELU. So it's a bit like, see the difference in the shape? It goes up, it's going like this, right? And then it goes like this. It changes the, I forgot the term, sorry, it's a mathematic. So this goes like that, and then it goes into a linear function, pretty much. Sorry, so, yeah, that's right. And what else? Let's do another one, Swish. Swish, swish, swish. It's a song. My daughter kind of sings that a lot. Swish, swish, swish. So it goes downwards, then up again. Notice that it goes below 0, and then it goes almost like linear from here, right? It's almost. Right, so that's it. I finished the module 2. I hope you enjoyed this course, module 2. It looks good so far. It's not very difficult just yet, but I'm suspecting that the closer we get to the end, it's going to get a bit more difficult, but that's where the fun is, right? Okay, I'm going to save this because you get a certificate, right? So I recommend you to take this course because you get a certificate. I mean, once you finish all the modules, you get a certificate and you can share it on your network, and everyone is going to be quite impressed if you do a course on neural networks. And it's like there's such, anyway, you know Kaggle, I'm sure. If you don't, go to kaggle.com and take a look. There's so much material there to learn data science, AI, and then you have so many data sets if you want some data to play with. Thank you so much for joining us today in this course. I'll see you again soon. Happy coding. Bye-bye.